everyone, we're Team Hotel and our project is called Eye Tests on Demand. So everyone is familiar with visual acuity tests, where you book an appointment with an optician and sit for 20 to 30 minutes reading optotypes from a chart. These can cost up to £30. Let's take a look at some statistics. Looking at adults when asked why they hadn't taken a sight test in the last 2 years, 19% said they didn't have time, 45% said they didn't think it was necessary, and 16% said they had concerns about the cost of the test. Only 59% of UK adults found it easy to book an eye test. And with children, 20% of them do not have regular eye tests, and worryingly, 20% of students starting their reception year have been found to have an undiagnosed vision problem. In 2008, the cost to the economy of the sight loss was £6.5 billion. This number is likely to increase as the number of people with sight loss increases. And almost 2 million people in the UK are living with sight loss, and that's approximately 1 person in 30. Despite all of this, 50% of vision loss can be avoided if people have regular eye tests every 2 years. But as we have seen, there are barriers to use eye tests, such as time constraints, difficulty booking, and costs. So that's where we come in, with public eye tests. Imagine yourself in a shopping centre or in a waiting room. You come across a TV with a QR code that you can scan using your phone, and you can take your eye test there and then. In under 2 minutes, you can get results on whether you should have treatment and a detailed report about your test performance.
We've implemented a system which performs these public eye tests. Our system is split up into 3 components: the server, the TV, and the phone. So the TV is initially configured by the TV operator. They put in physical parameters for the test, which is necessary to calculate the correct size to display the optotypes on the screen, and the various configuration for the procedure. The user then scans the QR on the screen and goes to the test page, inputs the data, and they receive results at the end of the test. So the strategy we use is a staircase algorithm, which is implemented on the server, so everything's driven by the server. And in order to avoid overestimating visual acuity, we have overcrowding techniques. So that includes crowding bars displayed around individual letters and the ability to display multiple letters on a single time on the test. So the server keeps track of multiple TVs, multiple phones, and the pairings between them, and it drives multiple tests concurrently. For privacy reasons, we have HTTPS everywhere, and we also don't keep data we persist data for just the minimum time necessary to provide the user with a result. So the TV, we'll have a brief look at each component in turn. So the TV, you can see it here in its ready state. The TV accurately renders optotypes to test for visual acuity specified by the server. And we also have support for children's optotypes, so that kids don't get bored when taking the test. The phone just guides the user through the test with text instructions, and we display optotypes for the user to provide input to the system. So results are in 2 forms. Firstly, we have a simple treatment recommendation, which is provided on screen to the user, and we also have the option to send an email summary to the user, and that looks like that. And you can see that we provide 4 different types of visual acuity measurement, as well as the graphs of the staircase algorithm for each eye. On the right eye in particular, you can see that we allow the user to make 1 mistake, but then and don't penalise them for that, and continue the test as expected. So just a few things that areas we consider we succeeded in. We achieved a highly abstract and modular design, which made it very easy to extend what we'd already designed initially. And the server-driven architecture which we chose, really that worked well for us. So the next steps would be to run a clinical trial with comparing the automated test results to actual manual tests, which are already implemented. Despite producing quite a thorough risk report, we didn't account for all risks, such as offending the user with the choice of letters chosen by the algorithm. But yeah, we'd like to thank very much our client for their helpful medical advice, and we couldn't thank that one. Thank you very much.